in search of the genetic footprints of Sumerians. For millennia, the southern part of Mesopotamia has been a wetland region generated by the Tigris and Euphrates rivers before flowing into the Gulf. This area has been occupied by human communities since ancient times, and the present-day inhabitants, the Marsh Arabs, are considered the population with the strongest link to ancient Sumerians. Popular tradition, however, considers the Marsh Arabs as a foreign group of unknown origin who arrived in the marshlands when the rearing of water buffalo was introduced to the region. To shed some light on the paternal and maternal origin of this population, Y chromosome and mitochondrial DNA variation was surveyed in 143 Marsh Arabs and in a large sample of Iraqi controls. Analyses of the haplogroups and subhaplogroups observed in the Marsh Arabs revealed a prevalent, autochthonous Middle Eastern component for both male and female gene pools, with weak Southwest Asian and African contributions, more evident in mitochondrial DNA. A higher male than female homogeneity is characteristic of the Marsh Arab gene pool, likely due to a strong male genetic drift determined by socio-cultural factors, patrilocality, polygamy, unequal male and female migration rates. The Near East is well known for its important role in human history, particularly as a theater for great historical events that changed the face of the world during the Neolithic period. The temperate climate and fertile soil brought by the continuous flooding of the Tigris and Euphrates rivers made the Mesopotamian region ideal for early revolutions in agriculture and farming. In particular, the southern part of Mesopotamia, the delta between the two rivers in present-day southern Iraq, has been historically known as the Garden of Eden, biblical name, or Sumer land, the land of Abraham. Mesopotamian civilization originated around the 4th millennium BCE in the low course of the Tigris and Euphrates rivers. This alluvial territory, which emerged progressively by soil sedimentation, attracted different populations from the northern and eastern mountains, but whereas traces of their culture are present in the territory, as documented by the Ubayyid Eridu pottery, nothing is available for their identification. Only two groups of populations who arrived later and in larger number left historical records: Sumerian and Semitic groups. The Sumerians, who spoke an isolated language not correlated to any linguistic family, are the most ancient group living in the region for which we have historical evidence. They occupied the delta between the two rivers in the southern part of present Iraq, one of the oldest inhabited wetland environments. The Semitic groups were semi-nomadic people who spoke a Semitic language and lived in the northern area of the Syro-Arabian desert breeding small animals. From here, they reached Mesopotamia, where they settled among the pre-existing populations. The Semitic people, more numerous in the north, and the Sumerians, more represented in the south, after having adsorbed the pre-existing populations, melted their cultures, laying the basis for Western civilization. The Mesopotamian marshes are among the oldest and, until 20 years ago, the largest wetland environments in Southwest Asia, including three main areas: the northern Al-Hawizah, the southern Al-Hamar, and the so-called Central Marshes, all rich in both natural resources and biodiversity. However, during the last decades of the past century, a systematic plan of water diversion and draining drastically reduced the extent of the Iraqi marshes, and by the year 2000, only the northern portion of Al-Hawizah, about 10% of its original extension, remained as functioning marshland, whereas the central and Al-Hamar marshes were completely destroyed. This ecological catastrophe forced Marsh Arabs of the drained zones to leave their niche. Some of them moved to the dry land next to the marshes, and others went into diaspora. However, due to the attachment to their lifestyle, Marsh Arabs have returned to their land as soon as the restoration of marshes began, 2003. The majority of the subjects analyzed in this study are from the Al-Hawizah marshes, the only natural remaining marsh area in southern Iraq. The ancient inhabitants of the marsh areas were Sumerians, who were the first to develop an urban civilization some 5,000 years ago. Although footprints of their great civilization are still evident in prominent archaeological sites lying on the edge of the marshes, such as the ancient Sumerian cities of Lagash, Ur, Uruk, Eridu, and Larsa, the origin of Sumerians is still a matter of debate. With respect to this question, two main scenarios have been proposed. According to the first, the original Sumerians were a group of populations who had migrated from the southeast, India region, and took the seashore route through the Arabian Gulf before settling down in the southern marshes of Iraq. The second hypothesis posits that the advancement of the Sumerian civilization was the result of human migrations from the mountainous area of northeastern Mesopotamia to the southern marshes of Iraq, with ensuing assimilation of the previous populations. Over time, the many historical and archaeological expeditions that have been conducted in the marshes have consistently reported numerous parallels between the modern and ancient lifestyles of the marsh people. Details such as home architecture, particular arched reed buildings, food gathering, grazing water buffaloes, trapping birds and spearing fish, rice cultivation, and means of transportation, slender bitumen-covered wooden boats called tarada, are documented as still being practiced by the indigenous population locally named Madan, or Marsh Arabs. This village lifestyle, which has remained unchanged for 7 millennia, suggests a possible link between the present-day marsh inhabitants and ancient Sumerians. However, popular tradition considers the Marsh Arabs as a foreign group of unknown origin, which arrived in the marshlands when the rearing of water buffalo was introduced to the region. In order to shed some light on the origin of the ancient and modern Mesopotamian marsh populations, which remains ambiguous in spite of all the above-mentioned theories, the genetic variation of a sample of Marsh Arabs has been investigated both for the maternally transmitted mitochondrial DNA and the male-specific region of the Y chromosome. The sample consists of 143 healthy, unrelated males, mainly from the Al-Hawizah marshes. For each subject, the Marsh Arab ancestry, at least for the last 4 generations, was ascertained by interview after having obtained informed consent. The collection of their blood samples was carried out in different villages during a field expedition. For comparison, a sample of 154 Iraqi subjects, representative of the general Iraqi population, was investigated for both mitochondrial DNA and Y chromosome markers. This sample is mainly composed of Arabs living along the Tigris and Euphrates rivers. In addition, the distribution of the Y chromosome haplogroup, J1 subclades, was also investigated in 4 samples from Kuwait, Palestine, Israeli Druze, and Khuzestan, southwest Iran, as well as in more than 3,700 subjects from 39 populations, mainly from Europe and the Mediterranean area, but also from Africa and Asia. 2 hypotheses have been proposed for the origin of Marsh Arabs. 1. They could be aboriginal inhabitants of Mesopotamia correlated to the Old Sumerians. 2. They could be foreign people of unknown origin. Although the origin of Sumerians has yet to be clarified, the 2 main scenarios, autochthonous versus foreign ancestry, may have produced different genetic outcomes, with Marsh Arabs being genetically closer to Middle Eastern groups or other populations, for instance those of the Indian subcontinent. Thus, in order to shed some light on this question, Marsh Arab population was investigated for mitochondrial DNA and Y chromosome markers. Due to their characteristics, uniparental transmission and absence of recombination, and their wide data sets, they are, at present, among the best genetic systems for detecting signs of ancient migration events and to evaluate sociocultural behaviors. Although different Western European mitochondrial DNA haplogroups were present in the Middle East in Paleolithic times, they cannot always be interpreted as markers of Middle Eastern origin. For example, even if the mitochondrial DNA haplogroup H evolved in the Middle East circa 18,000 to 15,000 years ago, different H subgroups observed in this region, albeit at a rather low frequency, such as H1, arose outside and are most likely the result of gene flow from Europe. Y chromosome variation, like that of mitochondrial DNA, is highly geographically structured. However, Middle Eastern haplogroup J, which accounts for the great majority of paternal lineages of this region and marks different migration events toward Europe, Africa, and Asia, does not display, at present, evidence of back migrations. Haplogroup J, with its two branches, J1 M267 and J2 M172, is a Y chromosome lineage dating to about 30,000 years ago. Its place of origin is still under discussion, but it is considered a landmark geographically linked to the Near Eastern region, where the agricultural revolution and animal domestication appeared for the first time. Accordingly, the frequency distribution of HGJ shows radial decreasing clines toward the Levant area, Central Asia, the Caucasus, North Africa, and Europe from focal points of high frequency in the Near East. Although both clades involved in situ and participated in the Neolithic Revolution, their different geographic distributions suggest two distinct histories. While J2M172 has been linked to the development and expansion of agriculture in the wetter northern zone, and is also considered the Y chromosome marker for the spread of farming into Southeast Europe, J1M267 has been associated with pastoralism in the semi-arid area of the Arabian Peninsula. Despite this purported initial association, no evidence of pastoralism has been reported in the marsh area, where one of the J1M267 highest values, 81.1%, has been observed. Only a small proportion of the Marsh Arab gene pool derives from gene flow from neighboring regions. On the paternal side, our phylogeographic data highlight some Southwest Asian-specific contributions. Different from the Iraqi control sample, the Marsh Arab gene pool displays a very scarce input from the northern Middle East, and virtually lacks Western Eurasian and Sub-Saharan African contributions. On the other hand, the absence in both Iraqi groups of the North African E-M81 branch speaks against substantial patrilineal gene flow from this region. On the maternal side, a significant East-Southwest Asian component is present among Marsh Arabs. This observation is likely due to recent gene flow, although it is worth noting that the ancient Silk Road passed through the Iraqi region from Basra to Baghdad. In comparison with the general Iraqi population, Marsh Arabs are characterized by an important lower Y chromosome heterogeneity. The J1M267 alone characterizes more than 80% of the Marsh Y chromosome gene pool. Although patterns of lower male than female heterogeneity have been reported in many populations and usually ascribed to patrilocal residence, such a scenario can explain only part of the large difference observed in the geographically isolated marsh population. Among the different factors, ergo polygamy, unequal male and female migration rates, and selective processes, that can differently affect the extent of mitochondrial DNA and Y chromosome heterogeneity, non-random mating practices common in the area, in association with cultural beliefs that support polygamy, may have contributed to cause the difference observed in the Marsh Arabs. In conclusion, our data show that the modern Marsh Arabs of Iraq harbor mitochondrial DNAs and Y chromosomes that are predominantly of Middle Eastern origin. Therefore, certain cultural features of the area, such as water buffalo breeding and rice farming, which were most likely introduced from the Indian subcontinent, only marginally affected the gene pool of the autochthonous people of the region. Moreover, a Middle Eastern ancestral origin of the modern population of the marshes of southern Iraq implies that, if the Marsh Arabs are descendants of the ancient Sumerians, also Sumerians were not of Indian or Southern Asian ancestry. Although the Y chromosome age estimates deserve caution, particularly when samples are small and standard errors large, it is interesting to note that these estimates overlap the city-state period which characterized southern Mesopotamia, and is testified to by numerous ancient Sumerian cities: Lagash, Ur, Uruk, Eridu, and Larsa.